So this chapter, before I start, AS chemistry is first year chemistry, A2 chemistry is second year chemistry, and both the Imat and A-level exams want you to know both the years, so AS and A2 combined. And in AS chemistry, there is around 11 chapters, and same goes for A2 chemistry. So in total, you have like uh, 22 or 23 chapters, if I'm not wrong. And this chapter is actually not chapter number 1, but it's chapter 2 of the AS chemistry. But I'm doing atomic structure today. This chapter is chapter 2, but I'm doing it today. And chapter number 1 is actually stoichiometry. But the reason I'm not doing stoichiometry today is because stoichiometry is heavily maths based, and you need to know a few things before going to stoichiometry. So this chapter really gives you the ground for going into chapter number 1. So that's the reason I'm starting with this chapter. So let's start then. Okay. Atomic structure is all about the structure of our atoms. Now, atoms have two charged particles and one uncharged particle. So we have protons, electrons, and neutrons. So protons obviously are positively charged, electron are negatively charged, and this uncharged particle is neutron. Now, if I have two charged plate, one positively charged and another negatively charged, and I pass a proton here. Let's say this is a proton. So will it deflect like this, or it will go like this? Now, because this is positively charged, it will get attracted by this negative charge. So a proton will be attracted to the negative charge. And similarly, if this was an electron, then it would be attracted to the positive plate. And if it was a neutron, meaning it is uncharged, it will pass straight through. Now, the nucleus contains protons and neutrons, collectively known as nucleons. So protons plus neutrons means nucleons. And the mass is concentrated at the nucleus of an atom. So the positively charged protons are in the nucleus, while the negatively charged electrons orbit the nucleus in the shell. So if I have this atom, this is the nucleus, and this orbit is where the electrons are orbiting, whereas the positively charged protons and neutrons are concentrated at the nucleus. So now comes the knowing the symbols. Okay, so any chemical symbol will have a mass number and an atomic number. Atomic number is the proton number, and the mass number is basically protons plus neutrons. So when they add up, you will get the mass number. It's usually at the top, and the proton number is usually at the bottom, this one right here. But sometimes this can be reversed, and you don't really need to know why, but just know that the mass number is always the bigger value, because mass number is the number of protons and neutrons in an atom. So now that we are done with this, let's move on to isotopes. So isotopes are atoms with the same number of protons and electrons, but different number of neutrons. They have the same atomic number, but different mass number. So the number of protons remains the same, but what changes is the neutron number. So because the neutron number changes, this will affect the mass number. So the mass number will change because the neutron number changes. So if I have, let's say, hydrogen 1,1, this is not an isotope. You will find this on the periodic table. isotopes cannot be found on the periodic table. So hydrogen 2 1 now. So this changes. So this 2 is basically the mass number. And the reason that it changed is because there was an addition of 1 neutron. You can see that the proton number remains the same in both the chemicals. So the chemical properties of isotopes are identical, whereas the physical properties such as the density can differ. That's everything you need to know about isotopes. All right, so now that we're done with isotopes, this is the main part that I want to focus today. And you'll find this a lot in your exams, the electrons in an atom. So what is electronic configuration? You might have seen this in your Imat or A-level exams. Electron configuration is the arrangement of electrons in an atom. So the way the electrons are arranged in an atom is called electronic configuration. Now, please focus on this part that I'm going to explain, because this comes a lot in your exams. Electrons are found in energy levels called shells. And there are 4 shells in an atom. So there are 1, 2, 3, 4 shells. So basically, let's say this is the nucleus. This is 1 shell. This is the 2nd shell, 3rd shell, and similarly the 4th shell, like this. But what's more important is that these 4 shells have a number of subshells, and each shell can hold a number of electrons. So let's say this is the 1st shell. This is the nucleus, and this is the 1st shell. This 1st shell has a number of subshells, all right? So these are called subshells. And the subshells are called S, P, and D. There are 3 subshells, S, P, and D. S can hold a maximum of 2 electrons. P can hold a maximum of 6 electrons, and D can hold a maximum of 10 electrons. And the first shell can hold the S subshell. So you might have seen this electronic configuration in your exams or notes. So 1s2, 2s2, 2p6, 3s2. I'll explain what this is. But for now, know that there are shells, there are 4 shells, and each shell will contain a number of subshells. So the first subshell, which is this one, can hold an S subshell, which means that when I write 1s, this can hold 1s only, and an S subshell can hold a number of 2 electrons. So a maximum of 2 electrons, so I'll write 2. Now, moving on to the second shell, the second shell can hold 2 subshells, the S subshell and the P subshell. And the S can hold 2 electrons, but the P can hold 6 electrons. So when I write the second shell, this is the first shell. When I write the second shell, 1s2, 2s2, this is the first subshell, this is the first subshell, and the second subshell in the second shell is the P subshell, which can hold a maximum of 6 electrons. So I start with the first, which can hold 1 subshell, the S subshell. Then I move on to the second, shell, which can hold 2 subshells. So one like this, and then the P subshell can be this right here, doesn't matter. But the main thing is the second shell can hold 2 subshells, which are S and P. So the third subshell right here, can hold 3 subshells, the S, P, and D. Now the D shell can hold maximum of 10 electrons. What do I mean? Well, I've written the first subshell, the second subshell, the first shell, the second shell, right? Now I move on to the third shell, which is 3. So I start with the S, 3s2, 3p6, right? Because P can hold 6 electrons and S can hold 2 electrons. And then I move on to the D subshell. So 3d, and D can hold a maximum of 10 electrons. So I write 10 right here. Now, that is shells and subshells. So it will get more clear when I do actual examples from the exam. But for now, if everything is clear, you can write yes in the chat. This way I can know if you guys have any question or not. What are orbitals? I'll get to orbitals later. But for now, I'm talking about shells and subshells. So orbitals will come on later on. Okay, so now let's do an example. This is orbitals, all right? I'll get to orbitals now. But for now, I'll do some examples, all right? And electron configuration is the number of electrons in an atom. So what if there are more than 4 shells? What if there are more than 4 shells? There can't be more than 4 shells, Abdullah. There's a maximum of 4 shells only. You'll never get to 4 shells. And they usually don't give questions that have more than 4 shells, because then the electron number will be so big and you won't get a lot of time to fill the 4 shells. So it's mostly you'll be limited to 3 shells. All right. So let's do this example. A very popular question that comes in both the Imat and A levels, the oxygen configuration. So this is the proton number, right? 8 electrons. This is the proton number. That means it's also the electron number. So oxygen has 8 electrons, right? So 8 electrons. So I start with the first shell. The shell number 1 can hold the S shell, right? Which can hold a maximum of 2 electrons. So I write 1, I write S, and then I write 2. This 2 means the first shell, the S subshell, can hold 2 electrons. Then I move on to the second shell. The second shell can hold 2 subshells, the S and P. And I told you earlier, P can hold 6 electrons, and S earlier can hold 2 electrons. Sorry, P can hold 6 electrons and S can hold 2 electrons. So I write the shell number 2. I write S. I write 2 because it can hold 2 electrons. So I'm done with 4 electrons. I'm left with 4 more electrons. So I write 2. I write 2p. And then how many electrons do I need here? Can someone tell me in the chat? Yeah, 4 electrons. So I write 2p4. So 1s2, 2s2, 2p4. And this total will give me the number of electrons in the atom. And this is what we call electronic configuration. So now I move on to, let's do this, and then I'll go to argon, because argon is a lot more confusing because it has a lot more number of electrons. So Na, or sodium, has 11 electrons. So I write 11. I write the first shell, the subshell, which can hold 2 electrons. So I'm done with 2. Then I write 1s2. Then I write 2s2, 2p6. So I'm done with 4, 10. I'm done with 10 electrons. So I only need 1 more electron. And what do I write here? I write 3, and then I'll move on to the S, because 3 can hold 3 subshells, the S, the P, and the D. So in total, 3 subshells, but I only need 1 more electron because I already have 10 electrons filled up. I need 1 more electron, so I'll write 3s1. If there were more than 11 electrons, let's say there were 13, then I write 2, and then I move on to 3p. But I don't need 3p because I filled the 11 electrons. So now I move on to the more complicated one, argon. So argon is 18 electrons. So, so argon will be 1s2, 2s2, then 2p6, right? And then I'm done with the 2 shell because it can hold the s and p orbital. I filled the s and p orbital. So I move on to the the third shell, which can hold 3 subshells. So I am done with 10 electrons. There's 8 electrons left. So I write 3s2. Now I'm left with 6 electrons. So I write 3p and I write 6. So 10, 12, and then 18. So this is the complete electron configuration. So 3p6. Now, what if there was more electrons? What if there was 3d as well? So this will come here. So now moving on to potassium. Potassium has 19 electrons, right? So I write 19 and I start filling the configuration 1s2, 1s2, and then I write 2s2, 2p6. I'm done with 10 electrons. There is 9 left. So I write 3s2 and then 3p6. I'm done with 18. And then I write 3d. But wait, after 3d, after the third shell, because the third shell has the maximum of the d orbital, so s, p, and d. After I fill after the d comes the fourth shell, which has s, p, and d again. But now there is one concept which is very tricky, and they'll ask you this again and again. So this concept is that when I move on to 3D, I write 4s and I fill the 4s first before I fill the d orbital. Why is that? This is related to energy. So electrons are filled according to the energy level of the shell. So the S shell has a lower energy than the 3D shell. So I fill the 4s first instead of filling the 3D. For example, I'm done with 2, 4, 2, 10, 18. So I'm done with 18 electrons. I need one more to get to the complete configuration. So what I write is, instead of writing one here to get me 19, I'll write 4s1 instead of 3D. You don't have to write the 3D. You will write 4s1. And suppose that there was a molecule or a chemical that had, instead of 19, let's say it had 23. Okay, this is not potassium, but just let's say for the sake of the argument. So let's say there was 23 electrons. So let's do that. So I'm done with 18 electrons, right? 10 and 18. So I'm done with 18 electrons. I need 4 more. Sorry, I need 5 more. So I'm done with the 3p. Then I move on to 3d and I write 4s. So as I said, I fill the 4s first because the 4s has a lower energy level compared to the 3d. So I fill the 4s first. I have 18. The 4s can hold a maximum of 2 electrons. So I write 4s2. That means I'm done with 20 electrons. I need 3 more. So I write 3d right here. So I write 3d3. That means 2, 10, I have 10, 18, 19, 20, 23. So this is the electronic configuration for an atom that has 23 electrons. Remember, 4s is filled first, then 3d, then I'll fill the 3d. Let's say there was 30 plus electrons, which is very rare because that will take a lot of time. So let's say there was 30 electrons, then what I would do is I would fill the 4s and then I fill the 3d. So when I get to the 10 electron mark, because the d orbital, the d shell, as I said earlier, the d shell can hold a maximum of 10 electrons. So when I get to the 10 electron mark, right? Wait a minute. Yeah. So when I get to the 10 electron mark, when the d shell gets to 10 electrons, I move on to the 4p. then I fill the 4p, and then if I want, I can also fill the 4d, but I won't usually get to the 4d mark. So that was electronic configuration. Now I go to the orbitals. So what is orbitals? Now, orbitals are region of space around the nucleus which can hold two maximum electrons. So let's say I have this nucleus, right? Then this is the electron configuration where this is the first shell, this is the first shell. So the first shell can hold the S shell, subshell, right? And this subshell can hold a maximum of 2 electrons. Now, how do I fill orbitals? The subshells, each subshell has a number of different orbitals. So orbitals are found in subshells. What do I mean by that? Well, the S orbital has the S subshell has one orbital. The P subshell has 3 orbitals, 1, 2, and 3. These boxes refers to the orbitals. So the S subshell has 1 orbital, the P subshell has 3 orbitals, and the D subshell has 5 orbitals. And as I said earlier, each orbital can hold a maximum of 2 electrons. So this will get more clear when I do an example. Let's say I have oxygen, and the electronic configuration I did earlier as well. It's 1s2, 2s2, and 2p4, right? So that means, so I write the electronic configuration 1s2, 2s2, and 2p4. So the S subshell has one orbital, right? And one orbital can hold 2 maximum electrons. One orbital can hold 2 maximum electrons. So I'll write the orbitals first. So this is also an S subshell, right? So the S subshell has one orbital. The P subshell has 3 orbitals. So I'll make a box, and these are 3 different orbitals. So S has one orbital, S has one orbital, P subshell has 3 different orbitals, and each orbital can hold a maximum of 2 electrons. And I'll write the electrons like arrows. So I'll start by like this. Now start filling each box or orbital with 1 electron at a time in each orbital. So there is a rule that says you fill the orbitals with 1 electron first. When all of the orbitals are filled, then we move on to the filling the unfilled orbitals. What do I mean? Well, let's say, so I have 8 electrons in oxygen, right? 8 electrons. So this is 1 electron. Now I won't do this. I won't make an arrow in the same orbital. I'll move on to the next orbital. So this is the second electron. This is the third electron. This is the fourth electron and the fifth electron. Now, do I have any unfilled orbitals? No, I don't, because all of the orbitals have 1 electron each. So when I get to when all of the orbitals are filled, then I move on to the S orbital so that I can fill the S orbital as well. So I'm done with 5 electrons. This is the 6th electron. This is the 7th electron, 8th electron, and now I'm done. So since oxygen had 8 electrons, I start filling my 1s first. Then I move on to the 2s orbital. I write 1 electron in the 2s orbital. In the 2p orbital, I write 3 electrons that are unshared. So I remember this rule. You fill the orbitals with 1 electron first. And when you complete all the orbitals, you'll move on to filling the rest of the orbitals. So let's do another example, this argon. So let me just go here and copy the configuration of argon. So argon is 4018, where 18 is the number of protons and electrons. So 1s2, 2s2, 2p6, 3s2, and 3p6, right? So 10, 18, right? Now, I move on to drawing the orbitals. The s orbital has the s shell has one orbital. So the s shell has one orbital. The p shell has three orbitals. So the p shell has three orbitals. These are three different orbitals. Again, s shell has one orbital. The s subshell has one orbital. The p subshell has three orbitals. So I write the orbitals like this. Now I fill the electrons. Remember there's 18 electrons. So I write 1 electron, 2, 3, 4, 5, 6, 7, 8, 9. So I fill the electrons so that I don't have any unfilled orbitals left. Now that I don't have any unfilled orbitals, I move on to filling the orbitals. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 2, 5, 6, 7, 8, 9. So I have 9 electrons. This is the 10th electron, 11, 12, 13, 14, 15, 16, 17, and 18. So this is how I will fill my orbitals, so that I fill the unfilled orbitals first, and then I move on to completing the orbitals. So now, is there anything else? Yeah, this is another very important concept known as filling ions. Now, let's say, for example, I had nitrogen, which has 7 electrons. So the electron configuration would be 1s2, 2s2, 2p3, 3, 4, 5, 6, 7. But now nitrogen is -3, N-3 now. So it's an ion now. So when it becomes an ion, -3 basically means that it will gain 3 electrons. Nitrogen gains 3 electrons. So it's no longer 7, but it becomes 10. So now nitrogen is 10. So what would be the new configuration of the nitrogen with -3? I write 1s2, 2s2, 2p. Instead of writing 3 now, I'll write, because nitrogen gained 3 more electrons, I'll write 6. So 4 plus 6 gives me 10. So I have 10 electrons. Now, moving on to aluminum. Let's say aluminum has 13 electrons. So 1s2, 2s2. This is basically the configuration of aluminum with 13 electrons. But now it's aluminum with +3 charge. That basically means aluminum lost 3 electrons. So when it loses 3 electrons, instead of it being 13, now it's actually 10. The proton number stays the same, but I'm talking about the electron number. So the electron number would decrease to 10. Now I have 10 electrons. So the new configuration would be 1s2, 2s2, 2p6, right? Now I have 10 electrons. So will I write this or no? I won't, because I'm done with 10 electrons. I no longer need these shells now. So this is how we draw the shells for ions. Now, finally, moving on to ionization energy. Ionization energy is the energy required to remove 1 mole of electron from 1 mole of gaseous atom. What do I mean by this? So let's say I have Sodium, right? So when sodium loses an electron, it would become plus, right? Similarly, when aluminium becomes aluminium plus, it will lose an electron. So the this is known as the first ionization energy. When an atom or chemical loses one electron, we call it the first ionization energy. So the first ionization energy is the energy required to remove 1 mole of electron from 1 mole of gaseous atoms to form 1 mole of gaseous plus one ion. Because it lost one electron, it would become plus one. And this is an example where sodium loses one electron and becomes Na plus one. So similarly, this is the second ionization energy. When aluminium plus one becomes aluminium plus two. Now it has lost two electrons. So it will become, this is the second ionization energy. Similarly, third ionization energy is when aluminium 2 plus becomes aluminium 3 plus. And in doing so, will be called the third ionization energy. Now, ionization energy is affected by some stuff. So what are the factors affecting ionization energy, right? The factors that affect ionization energy. The first one is the charge of the nucleus. So the number of protons basically. So if I have more protons, right, that means there would be a higher attractive force because this is the nucleus, this is the electrons. And let's say this is the positive charge in the nucleus, this is the negative charge. And these are the electrons, these are the protons. Now, if there were more protons, then I would have a higher attraction between the electron and the proton. So the protons would pull the electrons inwards. So I would need more energy to overcome this attractive force. Therefore, the charge of the nucleus affects the ionization energy. So the higher the charge, the higher the ionization energy. Also, the second thing is the distance from the nucleus. So let's say this is the nucleus with the positive charge, and I have this electron right here, which has a negative charge. Similarly, I'll draw another one, but this time it has a smaller radius. So the negative charge, the electron is right here, the proton is right here. So you tell me which one will require higher ionization energy. So this one right here, the second one, exactly. This one right here, since it is closer to the nucleus, requires higher ionization energy compared to this one. This one right here has weak attractive force. The proton is not pulling the electron greatly, but this one right here has a much stronger electron attractive force. So the distance from nucleus, the greater the distance, the lower the ionization energy. All right. And the last thing is called the shielding effect. Shielding effect. What is shielding effect? Let's say I have two electrons. You don't need to know a lot about shielding effect. Just know that shielding effect is when the electrons repel each other. So if I had two shells, right? This is shell number one, this is shell number two. And the first shell can hold two electrons. The second shell can hold the S subshell and the P subshell. So in total, I can hold two electrons in the S subshell and 6 electrons in the P subshell. So I have these electrons right here. Now the electrons in shell number one since both are negatively charged, this one and this one, in shell 2, the electrons are also negatively charged, they would repel. And when I repel, the ionization energy would change. When the electrons repel each other, they get further away. So this electron will move away from the nucleus, from the proton. So the distance would increase and the ionization energy would decrease. So shielding effect would decrease the ionization energy because electrons move further away from each other because of shielding effect. Now, this was everything you need to know about shielding effect. So I have this one important question. This one right here. I picked it up from a recent exam, the Imat 2020. This also comes in A-level exams. So I'll give you 1 minute to solve this. If you can't, I will solve it myself. Okay, so I'm only left with 1 minute remaining for the class. So I'll solve it myself now. Is it D? Yes. Let's see if it's D or not. They're saying it's D, so let's do D first. Let's see the question. In which species are the number of electrons and neutrons the same? So people are saying D, so let's do D first. Now, the neutron number is calculated using the proton and the mass number. So yes, let's see if it's D or not. So the neutron number would be the mass number minus the proton number. So the mass number is 18, proton number is 8, and I get 10 neutrons. This 10 refers to the neutrons. Now, I had 8 protons, right? I had 8 protons, but 2 minus means that this 8 protons means electrons as well. Now, 2 minus means I gained 2 electrons other than the 8 electrons. So I get 10 electrons as well. And yes, you guys are right because both the electron number and the neutron number is same. Both are 10, so the answer is D. I'm not doing the rest of them because you get the concept, right? Where do I find the recorded class? You can't get the recording. You have to pay for the recording because I'll explain in the Discord if you want, but the class is ending, guys. So I hope you enjoyed and learned something. I'll